Hello, welcome. Thanks for joining us in class again. Today we're having logarithm. Like we started in the previous class, we started with logarithm and we'll progress with define logarithm by saying that log of a number to a particular base is the number of times the base will be raised to give that number. Again, the log of a number to a particular base is the number of times the base will be raised to give that number. So when logarithm is presented in form of equation, this definition is going to be very useful. However, today we'll be looking at the laws governing logarithm. Very simple, very simple. If you've already mastered the laws of indices, this is going to be just a little step above that one, and it's very simple. So we'll just go that quickly. This video is not going to be long. Let's see. Now, if you have a log of this, just like in indices, in indices you already know that it said that a over n times a over m actually means an plus m. That's what we're going to mean. Now, if we look at this now, we're having this times this. By the time we open this up, it's going to be then log in base b of pq is actually going to be the log in base b of x plus the log in base b of y. This is it. This eventually means this. By the time you spread it out, this one settles it. So log is applied to both sides. This is base b. You have your multiplication sign here. It's no longer multiplication, it's addition like you already have it here. Now the same thing applies here. This is the quotient. This is the product rule. This is the quotient rule. In this case, see what happens. Now, then, log of b, p over q will be what? Will be log in base b of x minus log in base b of y. Simple. That's just simple. So this is what it's going to be. Just use the logarithm to spread it out. Now in this case, now you have the exponent part of it. This is log, sorry, let me repeat this. Pn. Now this rule states that when you have a power, in the next part of it, the power becomes the multiplicative. It's going to be n here, the n becomes the multiplicative, n log b q. So it's no longer going to be the power. By the time you want to make the log effective, this power will become a multiplication. So in a sense, for example, if we have log of 2 raised to the power of 3, let's say this is base 2. This is going to be eventually 3 times log 2 raised to the power of 2. So by the time I find the log of this number, let's say what's the log of 2? The log of 2, let's say for example, okay, let's say log 2 is going to be 3 times. What's the log of 2? Let's assume it's 0 point this, 0 point x, y, 0 point x, y, z. This is going to be 3 times this, not raised to the power again. So we'll come to that when we start solving. So eventually, by the time the log become effective, you found the log of this number, it's no longer going to be raised to the power of this, it's going to be multiplied by. The same thing applies. If you're solving log, by the time you found the log of this number, you found the log of x, you found the log of y, you're no longer going to multiply, you're going to add. By the time you find the log of x here and find the log of y here, you're no longer going to divide. What you do is that you subtract. By the time you find the log of p here, you're no longer going to use the n as a power. You're going to do what? Multiply. So in this place where you have multiplication, you added. You have division, you what? Subtracted. In this place where you have the power, the exponent power, you're going to do what? You're going to multiply by the power. When you have already found the log of this, you look it up in the log table or you check with the calculator. Now, when we come here, this is another rule. This one is just statutory. That the log of a number to its own base is equals to 1. In other words, log 2 in base 2 is actually equals to what? 1. Or log 3 in base 3 is equals to 1. Let's say log 20 in log 20 is equals base 20 is 1. So any number, the log, if I also say log 100 in base 100, so it's giving us 1. So that's what that means. That's what the law says. Now let's get to the fifth law. The fifth law that we have here. It says the log of 1, 0, the log of 1, 0, the log of 1, 0. So log in base 2 of 1 equals to 0. Log in base 3 of 1 equals to log 1 is equals to 0. But if it is log 2 in base 2, 1, the same 1, 1, if it's the same, if the log of the number and the base are the same thing, it's going to be 1. But on the other hand, if it is just log 1 is equals to 0. So these are the rules, very basic rules. You have to put them in mind. They are not difficult, like I said when we started. You look at this, when you're given multiplication, you eventually have to add. After you have converted the number to the log form, you have looked it up in the log table. Once you found the equivalent in the log table, no longer the natural number, the normal number, you have to add. Once you found this in the log part, you have to sub minus. If you were given originally division, in here if you have the power becomes a multiplicative. If when you checked this and you found in the log form. I want to thank you for staying tuned. We just made this very brief. In the next video, we're going to start solving more questions. If you have a question, please put it down, like and share. Thank you so much.